average. And today, well, the temps were down under the cloud cover, 18 to 20 degrees in the city, and a top temp of 21 in the west. On the chart, a trough over the east, generating patchy rain and some isolated storms. And taking a look around the country, early showers expected in Brisbane tomorrow, and it'll be overcast with isolated showers.
Have you ever watched the weather and just thought, I have no idea what is going on? Well, you're not alone. A lot of people also don't feel like they have any idea what these mean. And personally, when I look at that, it just looks like a mess. I prefer the big colourful signs that say it's going to be 17 degrees today. It's going to be showering. But these are really important to geography. Today in class, we looked at synoptic graphs. This here is a synoptic graph. They're often identified by their lines, by the H's and L's that we see, and sometimes by their red and blue colour. Now, they show these for a little bit on the news every night. Wouldn't it be cool if you can tell your family, hey, I actually know what those lines mean. I know what they're talking about. Now, today in class, we did an activity where we looked at the water cycle, and it was really important at the start that we learn our synoptic graphs properly. Some of you had some issues with them, and so we're just going to re-look over how we actually read them properly so you can refer back and do this activity again. Now, synoptic, which is the name of these graphs, just refers to current. So this is the current weather, and this is taken as of today, looking at New South Wales and Australian weather. Now, if we look at a synoptic graph, what are we actually measuring? So there's three things that they're going to measure. The first is pressure, the second is wind, and the third is temperature. Now, all of these three things are really important to understanding weather as a whole, but also understanding how the water cycle works and how periods of heat and rain affect Australia and when they're going to be coming, so we can plan for future and plan for different seasons that are happening. Now, it's important to realize that in the atmosphere, there's always air. It's all around us. We breathe it in, we move around it, and sometimes the air can have different consistencies. It can be warmer, it can be colder, it can have a higher or lower pressure, or it can even be full of moisture, which is what we talked about today when we looked at rain. Now, our atmosphere tries to maintain a balance all the time, but because the weather and the air in the atmosphere is always changing, our weather is going to change too to try and maintain that balance or that homeostasis in the air. And that's how we have synoptic charts. So if we see here, these white lines here, on the screen they're black at the moment, these lines are called isobars. So can you all say that together? Isobars. Yes, I'll explain that now. So isobars mean pressure is equal. Can we all say that, class? Very good. Pressure is equal. Johnny, I'll just get you to sit up straight. Thanks. Awesome. So with pressure bars, with our isobars here, our pressure is going to be equal in the atmosphere. And notice how there are only a few on the page, and then there's a lot down here. In these sections, all of our pressure is equal, and in the spaces in between, our air is moving constantly to trying to get to those balance areas. So down here, where they're all closer together, we're having a lot of air in between here that's having issues, and up here it's all fairly stable. Now, air always moves, just like in other science that you're learning, always moves from a state of high pressure to low pressure. So we've got our little high pressure here, our little red sign, and our low pressure here in blue. And when you see them on a normal weather chart, they'll maybe in red and blue, or they may just have H's and L's. That's what that stands for, high pressure, low pressure. Now, what is happening to maintain this balance? Our high pressure is always going to move towards areas of low pressure, and our low pressure is always going to move towards areas of high pressure. And they have a set way that they move in our atmosphere. if we were to look at a clock, our clock normally ticks clockwise. When we have high pressure areas and high pressure isobars that we can see here with all the H's and one down here too, our hot air moves clockwise. This may be backwards for you. Our hot air moves clockwise. However, where all of our L's are with low pressure air, our low pressure air actually moves anti-clockwise. Now that's really important because the way that they interact is going to always be changing and shifting as they move towards each other. And it helps them to actually balance out better. You would have learnt this well in your activity today, and I hope that that analogy has stuck in your mind, but you can always refer back to this. High pressure, moving forward with the hour, low pressure, going the opposite direction. And these are all done to maintain the balance. However, this movement that's happening here, and what we can see here, it's something that you all know very well. It's called winds. And there is a lot of wind in our atmosphere all the time. So when your high pressure air is moving to a low pressure air, or when your low pressure is moving to a high pressure air, we get winds. And that's how we can feel the air moving in our atmosphere. Now, down here, we talked about this before, there are all of these tight isobars. Now, tight isobars represent an area where the wind is moving really, really, really fast. So all of these little sections in here where the air is trying to escape, they're all really enclosed and tight together, so they're moving quickly next to each other. However, in these areas up here that are really loose, our low pressure and high pressure air are really far away, and so they're not moving as rapidly because they're not close to each other. So they're interacting slowly. But when they're close together, they get faster. And we did this in our activity in class today. Now, there are many different air types. We can have warm air, cold air, moisture carrying air. Now we're really excited about the moisture carrying air, and we explored that a lot more today. But there are also many different ways that we can read all of these other extra symbols on our charts. So the main one that we're looking at are our low pressure troughs, our cold fronts, and our warm fronts. And also our direction and speed of the air. Now, with low pressure troughs, they're normally indicated by little dotted lines or sometimes by a straight line. And a trough in general, trough up here, not the horse's trough, these basically just symbolize unstable air. So any air that isn't in the quiet balance is really special to us because unstable air means rain. Where we see low pressure troughs moving through our graphs, that means that there's going to be air. And normally, they'll make them a blue color so you can easily see that. If we look back at our graph here, we can see some low pressure troughs here by the dotted lines. And you know what I think is really cool? When rain falls down, we think of it as blue drops. And when we see it on the graph, you can think of that as blue rain dropping down on our land. The next one that we're going to talk about is cold fronts and warm fronts. So cold and warm fronts can also carry moisture, air in them, but often they'll have more a mist or a fog kind of area where the clouds are a little bit denser and they'll be lower to the ground. Basically what happens is when a warm front and a cold front move next to each other, inside that area we're going to have warm air. And that warm air is where we start to get that fog and it's a little bit of a different temperature. And we may see some of them on the graphs, or you may have asked us, I know that Johnny had one of his graphs in class today and asked that question, and he had a little warm front area in his graph, and so in those areas you'll normally recognize more fog or mist, and sometimes a little bit of light patchy rain. Now, on each of our warm and cold fronts, there are little arrows or dots pointing different directions. the way that the arrows or the circles are facing is the direction that that front is moving. So kind of like an arrow points you in the direction, you know which way it's going. And in these areas, they are indicators of increased rainfall around these fronts. So let's look at our graph. Now this one we can see our hot air, we can see a little, we can see our troughs over here, and down here what have we got? Yep, that's right, we have a cool front coming in. And in this cool front, which directions are the arrows pointing? Up this way. So you know that that cool front is going to come and move along these lines here and probably hit down Victoria. That's cool because we can predict how the weather's going to happen. And when this cold front comes in, we're probably going to get rain with it too. Up here, we can see that the cool air is moving up this way and the hot air is moving up this way. But down along here in our rainfall patterns, that's where we're interested. So it doesn't look like Australia is going to be getting too much rain on this graph, apart from down here in Victoria maybe. However, what have we got here? Dotted lines mean rainfall. So there might be a little bit of rain sweeping down through the centre of New South Wales and Victoria.